Good morning, pre-algebra. Today we are going to cover lesson 43, surface area. Write down the title in your notebook and we're going to take some notes, and there'll be a little bit of drawing that you have to do, and also there's 3 examples, I believe. So let's get started with our definitions of surface area. The surface area of a solid is and you want to write this down in your notes. So the surface area of a solid is the combined area of the surfaces. So you're going to find the area of all the surfaces, the outside surfaces of the 3D figure. There are 2 types of surface area. There's total surface area and there's lateral surface area. The total surface area is the surface area of all of the sides of a figure. But the lateral surface area is the combined area of the sides of the solid and does not include the area of the bases. So it doesn't include the top or the bottom. It's just the area of the sides. It says we can find the lateral surface area of prisms and cylinders by multiplying the perimeter or the circumference of the base by the height. And I'll show you an example of that. So this needs to be in your notes. Example number 1, you want to draw this in your notebook. You have a cube. So see if you can do your best at drawing a cube. And the edges of the cube, you want to label them are 10 centimeters. So we want to find the total surface area of the cube. Remember, the surface area is the outside of the cube. And then you're going to find the lateral surface area of the cube. Okay, so the solution is, first, for A, all of the edges of the cube are the same length. So the length, the width, and the height of the cube are all 10. And the shape of each of its faces is a square. So if you find the area of one of the sides, let's say you find the area of that side, the area would be 10 times 10, so you would have 100. And there are 6 sides to a cube, so you would do 6 times 100 and you get 600 centimeters squared. So cubes are pretty easy because all the sides are the same, and you just have to remember that there are 6 sides to a cube. If you want to do the lateral surface area, and remember I told you the lateral surface area, oh, that doesn't move, does it? Okay, the lateral surface area is just the sides of the cube. So let me get a different color. So the sides of the cube would be just all the way around it, and not the top or the bottom. So you would not do the top or the bottom. So lateral is the front and the 2 sides and the back. So how many sides are there? There are 4. Well, we already know that each side is 100 centimeters because we did that previously. So instead of 6 sides, the lateral surface would just be 4 sides, so it'd be 400 centimeters squared. Another way to calculate this is, and I'm sorry this is confusing here. Another way to find the lateral surface area is to multiply the perimeter of the base by the height of the cube. So the perimeter of the base by the height of the cube would be 40 centimeters times 10. And I'm going to show you this particular example in the next one, so let's talk about that there, about how you do the perimeter times the height. All right, let's go on to example 2. Okay, so for example 2, you've got this building, and it's a regular shape, which most buildings are. Most buildings are not cubes. So you want to draw this onto your paper. And it says, before buying paint for the sides of this building, Malia calculated the lateral surface area. So we're going to find just the lateral surface area of this figure. Now remember, lateral surface area is just the sides. All of these sides, but it does not include the top and the bottom, because when they're going to paint this building, they're not going to paint the floor and they're not going to paint the ceiling, only the walls. Okay, so how we do this is, after you've drawn this, then what we're going to do is we're going to draw the base of the figure. The base is the bottom. So here we have a drawing of just what this would look like, the base of the building, if you looked at it like from the ceiling, if you just look down. And then we put all our measurements. So we have 12 here, just like 12 is there, 12 there, 15, 20, and all of your measurements all the way around. In order to find the lateral surface area, the easy way to do it is to just find the perimeter of this base. So add all of these together, all of the perimeter together, which is 118 feet, and then you multiply by the height, which is there, 10 feet. So you do 118 feet times 10, and you get your answer, which is 1,180 feet squared. And that's a pretty easy way to do this problem. So remember, to find the lateral surface area, you do the perimeter of the base times the height. So make sure that is in your notes. All right, we have one more example. Okay, before we get to that example, I want to just talk to you about nets. So a net is a two-dimensional image of the surfaces of a solid, and this is a net right there. That's basically taking a cube and, like if you had a box that was shaped like a cube, and opening up the box and laying it flat, okay? So this is called a net, and it helps us to visualize a solid's surfaces. So this is the net of a cube. See, there are 6 faces of the cube, and they're all squares. So that's an example of a net. Now let's use this concept of a net and go to finding surface area for our third example. Our third example is a cereal box, and we're going to estimate the surface of a cereal box, of the surface area, the entire surface area, not just the lateral, but the entire surface area of this cereal box. So it says to estimate. That's key because look, we have all kinds of fractions here. So the first thing you want to do is round everything. So draw this figure, go ahead and label it, and then let's round it. So 7 3/4 inches is closest to 8 inches. 12 1/4 inches is closest to 12 inches, and 2 3/4 is closest to 3 inches. So that's a lot better than working with our fractions because we're estimating. Okay, so our solution says that first we round to the nearest whole number before performing the calculations. And then it wants us to do this with a net. So here we have the surface area. We estimate the area of all the surfaces. So draw the net, and it tells you have the back, you have the front, you have the top, you have the bottom, and then you have the left side and the right side. So the area of the front, so I'm going to have to kind of, let's see how this is going to work. Okay, the area of the front of the box, and I don't really like this example, but we're going with it. So the area of the front of the box to me is right there, so let's hope this works. So this would be 12 right here, times 8, I believe, 12 times 8. So that's the front. Well, you have you have a front and the back. The front and the back will match. So right here, you have 8 times 12 for the front and the back. And both of those would be 96. Then you have the top. So I'll do that in a different color. See? So the top is here, and the top and the bottom match as well. So the top and the bottom. So the top is going to be 8 times 3. So 8 times 3 is 24. So that's the area of the top and the bottom because you have 2 that are the same. The next are going to be the sides, and the sides are going to be, and I'll do that in black, the sides would be the right side and the left side. So this is 3 and this is 12. So 3 times 12 would be 36. You have a right and you have a left, so you have 2 of those. So I don't know why this isn't moving, but down here, oh goodness, down there, oh, it did move. Let's see. There it is. So you have the area of the left side and the right side. This is 36 inches for both of those. And when you add all of that together, all of this together, you get 312 inches squared. And that would be the surface area of the box. And why would you want to know that? You would want to know that if you were in charge of packaging for the cereal company and you had to buy enough material for all of the boxes of cereal that you're going to ship to Keller, Texas, or wherever your hometown is. So that's one of the reasons that you would need to know surface area of a cereal box. Another reason you would want to know is if you were an artist and a graphic artist and you were in charge of designing all of the words and graphics that go on the outside of a cereal box, then you would want to know how much space you have in order to set it up on the computer and do your graphics. Okay, so let's go examples. Here is the practice set. We'll do that in class, but if you want to challenge yourself and try to do it, you can go ahead and do that. All right, have a great day. We will see you soon.